be in for a long haul, and we're going to spend some time, and we're going to talk about the topics that are still very important in chemistry there. And so we're going to spend some time in talking about chapter 11, and then we're going to spend some time and talk about chapter 12 if I finish chapter 11. And then tomorrow we will wrap up the entire semester of the lecture there. Whatever we can do, I hope that I have enough time to finish everything. But if not, then at least I will point it to you that these are the information, if you're planning on taking Chem 1 and 2, these are the information, the pages of the textbook that you need to read, and so on and so forth. Okay, so we will start with chapter 11. And again, if you want to take a look at the second and third exam, you can do so and come to my office either today during my office hours or tomorrow after lab. And you can stop by my office and take a look at your exam, and just to make sure that whatever questions you did not answer correctly, then you know how to answer those questions. Because the chemistry is always, and the science topics are always a cumulative topic, and whatever you have finished, you should expect to see them again in the future, and the application of those topics there in the future will show up again. And so that's something, it's always a good thing to learn from your own mistakes. Okay, so if you want to stop by, you're more than welcome to do so. I will bring your Scantron and the graded quiz number 3 back here on Thursday tomorrow. So you will get your quick quiz number 3 back, you'll get your homework back, those who haven't picked up your homework yesterday. And then you will get your Scantron for the third exam back. Okay, so that's the plan. Okay, so chapter 11 deals with the properties of liquid, solid, and we will be focusing on one thing. We're going to be focusing on what we call the intermolecular forces. Now, so far we've been talking about the electron distribution within a particular atom. And that's the atomic structure. We use quantum theory to explain and to describe how the electrons are being distributed. And that's very important because the electron distribution basically dictates the chemical and physical property of each atom. So we need to understand that in order to understand how atoms and molecules behave. And then we get into the situation where we have, after we know the electron distribution about the atoms there, what happens if they combine together to form a compound? So we talk about the chemical bonding, we talk about the fluid structure, how the electrons are being distributed between the atoms, or among the atoms, if you end up with the polyatomic molecule there, among the atoms there. How are the valence electrons being distributed? So we ask you to write the fluid structure and all that. And now, what happens if you have two molecules interacting with one another in close contact? And so that's going to be the focus there, and we use the term intermolecular forces there. That, again, has something to do with the charges each of the molecules or atoms bear when they are in close contact. Now, in chapter 5, we spend some time in talking about the gases there, and we say one of the assumptions there is that gas molecules are far apart from one another, so there is no interaction unless you compress them into a very small volume there. But liquids and solids, that's a different situation. Liquid and solid particles there, they are much closer to one another. And we know all of these chemicals, all of these compounds are made of protons and electrons and neutrons. And protons and electrons, they bear charges. So even though a molecule may be charged neutral, you have the same number of positive charge and negative charge within a molecule, and they have two different types of charges there. If you have another molecule close enough with this particular molecule, then there will be an interaction between the positive charge and negative charge within each molecule, or between the two molecules there. And this is where we have what we call the intermolecular forces there. So that's the topic that we're going to be talking about in chapter 11. Now, chapter 11 does cover liquids, solids. Okay, and we are not going to spend much time in talking about the solid. The chemistry of solid is, and we can probably spend another half semester talking about the properties of solids there. And so liquid and solid and gases there, each has their own individual behavior, individual characteristics there. But in this case, in chapter 11 there, we will only focus on the liquid part, okay, how liquid molecules behave, and how they liquid molecules interact with one another. solid and has some similarity there, and that's why the author put them in the same textbook there, in the same chapter in this textbook. But we will not be looking at the properties of solid, and that means you will not see topics related to solid chemistry on the final exam either. Okay, so we're just going to be looking at the intermolecular forces there. Now, this is probably something that we've seen on the internet, and the geckos little creatures there, they can climb on glass. The reason behind that is actually the intermolecular forces there. The molecules on the little paws of these little creatures there can actually interact with the glass molecule, and because of that intermolecular force, and that makes it strong enough for them to hold on to the glasses. They're very smooth surface there. Okay, so we need to ask, when we look at the behavior or interaction among molecules there, we need to ask all these different questions there. As a chemist, we are trying to understand how matter behaves. So water is a liquid, but why? Why it's not a gas at room temperature? Why does water boil at such a high temperature? Boiling point for water is 100 degrees Celsius, 212 degrees Fahrenheit. Why a small molecule only 18 grams? Why is the boiling temperature so high? And that has something to do with what we call intermolecular forces there. And ice float on water. Well, ice is water. Why solid ice has lower density than liquid water? Well, there's an explanation there based on the theory about intermolecular forces there. Oil and water do not mix. Now, what happens to the molecules there? Why can't you mix oil and water together? And when you pour liquids out, whether in space or on Earth, when you try to pour liquid out, you notice that the liquid will actually form a sphere droplet before it breaks away from the main body of the liquid. In this case, if you use water as an example there. So when you pour liquids out, you always have that the spherical droplet formed first. Okay. And then the elements that we have in group 7A, iodine is a solid, bromine is a liquid, chlorine is a gas. What determines the physical state of those elements belong to the same group there? And all of these questions have something to do with what we call the intermolecular forces there. And intermolecular forces also have something to do with the polarity of a molecule. If you're dealing with a polar molecule versus non-polar molecule, and that they have different types of intermolecular forces there. Okay, so in this case, we again in chapter 11 there, we separate the chapter into several learning objectives there. So we want you to be able to, in the first learning objective, we want you to be able to explain different types of intermolecular forces. Okay, and we have what we call dipole-dipole interaction, and we have hydrogen bonding, we have Lindon dispersion force. And those are the three major types of intermolecular forces there. And explain the fact that the intermolecular forces have on physical properties of substances, such as boiling point, melting point. Okay. And there is actually, we wouldn't call it periodic trend, there is a general trend that you can use to make a prediction based on the size of the molecule, based on the polarity of the molecule there. So we can actually make predictions about these properties, and simply by looking at the molecule, what's involved, and based on the types of intermolecular forces that we have among those molecules there, we can make predictions about their melting point, boiling point, and among other physical properties.